Good morning, class. Today we're going to look at working with Windows Presentation Foundation. So we have a new project, Shop Easy, that at this point is just exactly what we would have gotten from our template. So there is an app file, app.xaml, and a mainwindow.xaml file. And that's really all there is to this. So let's take a look at our main window. And you'll notice here that we have XAML, which looks a lot like XML. It has elements with a tag name, opening tag, and a closing tag. And then inside the element, we also define a number of attributes, which are key value pairs. So this would x:class would be the key, and shopeasy.mainWindow would be the value. And that's on through that. And then we also have a grid, which is one of our different containing elements. And what's important to understand is that this XAML actually compiles into C#. So this is actually defining an instance of the window class. And actually, this class here indicates that this is actually going to be subclassed as the main window. And if we jump to our main window, our code behind for that, which is always listed underneath in the Solution Explorer, notice the code behind is mainwindow.xaml.cs, so the same name, and that's how Visual Studio knows to organize it like that. And if we come in and look, we have a namespace like we're used to, and a public class main window, which extends the window base class. And then we have a partial keyword here. So just like in Windows Forms, where Windows Forms uses a partial class, Windows Presentation Foundation also uses a partial class. The big difference is in Windows Forms, it gives you this designer view, and then there's also a code view that you don't get to see that's actually buried, and you have to do a bit of work to get there. But as you're, for example, dragging things onto the visual editor, it's actually changing that code behind the scenes. Now, we can also use the toolbox drag tools over in Windows Presentation Foundation, and notice that it goes ahead and it just inserts this code for us. But we can go ahead and make changes to that as well directly here in the XAML. And that's actually what I would recommend you focus on doing to start with, is to learn how to write the actual XAML code. Don't try to use the visual editor. Focus on writing it as code. And the reason I say that is the big difference between Windows Forms and Windows Presentation Foundation is Windows Forms is built for a window that really doesn't change size. So everything you lay out is going to be exactly where it is. Whereas Windows Presentation Foundation, part of the expectation is that you're going to show this on different size devices. And for example, if you absolutely position a button using the margins like this, and then later on we display this at maybe on a 400 pixel wide screen, so a smaller device, what's going to happen is that's going to cut off your button. Now our button's over here and we no longer have access to it. So that's, generally speaking, not the best design strategy. We want to make sure that we actually support the screen size as it actually is. So rather than using the visual editor, we're going to be typing our code directly into the XAML window. And it's important to understand that the properties over here, what those are actually changing is the properties or the attributes of this XAML. And all these controls, we can actually just type up the name of the control directly and add it into our control here. Like if we wanted a checkbox, we could just go ahead and do a checkbox, and as soon as I finish with that, and it needs to be defined within the grid. That each element can only have one child. That's an important consideration. Unless it is one of these containers like the grid, like the stack panel. Those layouts will actually allow you to have multiple children. And if we zoom in, it's hard to see right now, but there is our checkbox floating right in the upper left-hand corner. And that will actually size based on what kind of container we have it in this case, the grid, because we only have one grid cell at the moment, this checkbox is technically filling up that entire grid cell, but it arranges itself in the upper left-hand corner of the available space, which is why it's showing up right underneath that main window in the corner there. Okay, so the next thing about XAML is, and Windows Presentation Foundation, is a lot of times we could build our whole application by just putting stuff into this window. And that's perfectly fine, but it does come with some challenges when our applications start getting larger. That starts breaking down, and it doesn't work as cleanly or well as we might like. It's kind of like when you first started programming and you put your entire program into that main CS file or that main Java file, and you had just one file that was just chock full of programs, and it was hard to reason about, and you had to scroll a lot to find what you were looking for. The same thing can happen in GUIs, and we have object orientation for dealing with some of that challenge in the programming side. On the GUI side, a lot of times we'll talk about what we call component-based design. So breaking up the GUI into smaller logical units we call components, which ideally embody a single activity. And that's what we're going to do today. We're going to actually create some components and practice a little bit of very simple component-based design. And we're going to do this with a shopping application. So this is going to be just an application to keep track of a shopping list for a store. And then we'll kind of organize that into maybe a shopping spree where we might have multiple lists, one for each store we're planning to go to. And in component-based design, we want to kind of break those up and have a single principle. So we want to think about, well, if we have a bunch of shopping lists, but we really want to just deal with a shopping list first. So we're just going to create a shopping list component to get us started. So we'll go ahead and add a new, and we want to come down and find a user control is actually what we use for most of our custom controls. So we're going to create a new user control, and you can see there user control. Let's go ahead and name this shopping list. And there we go. So right off the bat, you'll notice that it is kind of hard because I'm using dark mode to see the background of the control. One of the things you can do is down here, this toggle artboard background, it looks like a checkerboard. If you click that, it puts this kind of checked background behind everything, which makes it easier to see the borders, and also helps us see what parts might be transparent or translucent of our GUI so that we can reason about that, and if we want to change a background color, we can do that. Now, there's a couple attributes I want to touch on here, the design height and design width. These will change this design area, and since the shopping list, at least in my experience, is mostly long and skinny, I'm going to refactor this so it actually reflects that. So now it's long and skinny. Now the design width and design height only affects this designer editor window. It doesn't actually change the width or the height of the element at all. The width and height of any user component is going to be determined by the space that it can occupy. Now we can also set a width and we can set a height with just the width and height attributes, and those are suggestions that WPF will take into account as it's sizing and laying out the elements. But if it needs to, it will still stretch that out or squish it down if it has to. It'll try to follow our suggestions. Now we can also enforce a bit stronger restraint by saying min width and a min height. Those say it can't be any smaller than this, and also a max width and a max height, and that says the element can't be any bigger than this. So we can actually force the issue as well. But in this case, I'm going to leave it pretty much as it is. The other thing I'm going to do is to make this easier to write, and especially because this is a tall and skinny control, I'm going to switch from the horizontal split to the vertical split. So this button with a single line down the middle means that we're going to rearrange these editor panes so that they are split that direction, and for some reason it didn't give me my scroll bar on the bottom here that it normally should. So my shopping list is actually a bit off screen. That's annoying. Let's recenter that a bit. Yep. Oh, there's our scroll bar. It was just, must have been squished. Yeah, so it was squished and just giving me the arrows. Okay, and I'm going to zoom in a little bit, not that much. Maybe there, that looks good. Now we can kind of see our control, and we have an easier time seeing the actual XAML that creates the look of this control. Now, by default, all user controls start with the grid as the layout, but we don't necessarily have to stick to that. This is actually a good, or we need to talk about what we want to do here. I'd kind of like to have a shopping list across the top, and then immediately below that an editable box where we could put down what store we're actually going shopping in, and then the list all of the items that we're shopping for. And then we have to have a way to put those items in, so I think down at the bottom I'd like to have a text box and a button that says add to list. And so I could do that with a grid, but this is also kind of a good opportunity to show off a dock panel. So let's do a dock panel first. So at the very top, I'll do a text block, and we'll align that, or dock that, to the top with dock panel.dock top. In here, I'm going to say shopping list for, and to make this a little easier to see, I'll go ahead and drop this down to the next line. And that looks okay, but I want it maybe a little bolder, so maybe change our font weight to bold. And let's go ahead and text alignment, set that to center, so it's centered in the space. And let's go ahead and up the font size a little bit too. Font size, maybe 20 units. Yeah, so that looks pretty good. And let's go ahead and put a colon at the end of 4. And then underneath that, we'd want a text box. So this is what we can enter text into. And let's go ahead and set that to dock panel.dock top. And anything else on that? No, I think that's good. Now you'll notice that it by default stretches to fill this entire space. As soon as we put something else underneath this, it's going to snap up back to the top. So if we were, for example, to do a list view, which just prints a list of items, now you can see that text box is up here at the top. The list view is filling up the available space. So whatever kind of is the last piece declared fills up the available space in a dock panel, at least whatever is not anchored to one of the sides and or is the last thing declared. So we're going to leave that one unanchored, and then down here at the bottom we want a button for adding new content. And we'll go ahead and anchor that to the bottom, dock panel.dock bottom. And just above that we want or below that we want another text box. And this is going to be where we enter the item that we're going to be shopping for. And we'll set this one to dock panel.dock bottom. And I'll use a self-closing tag. And let's go ahead and move this list view all the way to the bottom here, and that puts it right there. You can see when I have the list view highlighted, it's highlighting the central space. All right, so that kind of gets us started. Now we want to, when we click this add item button, we want to take whatever is in this text box and add it to this list. Now in order to access the things that we've declared in XAML in the code behind, we have to give them a name. So at the very least we have to give this list view a name property, and because these are basically private variables, we'll use private variable naming conventions. So we'll start with a lowercase list. Let's call this items list view. And then the text box here, let's give it a name as well. Name equals item text box. So we're basically saying this is the item text box, this is the item list view. We could also give a name to the button, but there's another way that we can handle buttons as well, because we want to basically handle the click event on that button. So if we go to our code behind now, we'll see this is just a shopping list class. It's partial, it extends the user control, and we have our constructor. Now with the constructor of one of these partial classes, this initialize component is an extremely important call. What that does is that actually says I want to set up and execute all of the code that's generated from this XAML. So that's what actually makes all of these parts appear. If we were to delete that out of that backend code, what would happen is when we created a shopping list, it would just be an empty control. None of the stuff we defined in XAML would show up. That also means that we don't want to mess with anything that comes with the XAML until after this has been run. What we're going to do, though, is we're going to write ourselves an event handler. And event handlers usually don't have a return result, so we're just going to set that as void. We're going to leave this as the default private as well, because we don't want it accessed outside of this class. It's going to be accessed from the other side of our partial class. And since that's all part of the same class, it can be private. And let's call this add item to shopping list. And all event handlers take two arguments in C#. The first is an object called sender, and this is the object that actually sent the event that we're handling. And in this case, it's going to be that button, but we go ahead and declare it as an object, and if we want to treat it as a button, we have to cast it back to being a button. And this is just how they dealt with events generically. And the second one is an event args that are the parameters or description of that event that give us more information about what's going on with that event. Now for WPF, click events actually have a specialized form of this called a routed event args. So we'll go ahead and make this a routed event args. And then when we click on that button, what we want to do is we want to get the text, which is a string item, from that item text box, and we can get that by calling on its text property. So the text property will both set the text if we set it equal to something, or get the text from a text box. And because we gave it a name, we now can access it as a local variable. So now item, it contains that. And then we want to put this item into our items list view. So list view has a collection of items, so we can access that collection with the items property, and then we can invoke add and go ahead and add our item. So that will put it into that list so that it's now available. And then the last thing we want to do is we want to take that item text box and we just want to clear it. So we could either set its text to an empty string, or we can invoke this clear method. That's going to empty out that box. So what was in that box is now added to this list, and then the box is clear and ready for the next thing to be typed in. Now we need to set this as the event listener on our shopping list button here, and one of the ways we can do that is we can just add an event handler, in this case a click event handler, and we can supply the add item to shopping list. Now notice we can click new event to create one. That'll go to your code behind, put one in for you. Or because we've already written one and its signature, method signature, matches what the click event is expecting, we can just add that one, and that now will point at that shopping list. So this is one way of doing it. The other way we could do it is if we gave this button a name, like maybe we called this button right here in the initialize component, if we called it add item to list button, then we could say dot click plus equals and give the add item to shopping list. So that would also be an alternative, and this way works especially if you need to add more than one event handler. You can do that programmatically in the code behind. If you do it decoratively in the front, you can really only add one at a time this way, unless you use the special properties that let you add multiple children to a property, and I've never tried that, so I'm not sure if that would actually work. But generally speaking, a lot of times with these controls we only have one thing we want to trigger with the event handler, so this works perfectly fine. All right, so that's basically a shopping list. We've got our shopping list pretty much done. I might go ahead and grab just a little bit of the formatting we did here in terms of font weight, text alignment, and font size, and apply that to this editor box so that it looks like the list. That keeps us a little bit different from the text that's going to be in our list down here. Okay, so that would be our shopping list. Now, the next thing we want to think about is when we decide that we're going to have multiple shopping lists for different stores. How are we going to display those? How are we going to allow the user to kind of move between those? How do we navigate between those lists? And of course, we could possibly put more than one in the window, but for this app, I'm kind of designing it as though we're going to put it on maybe a Windows mobile device that has a small screen real estate. So we really want to be able to swap between the screens. And the easy way of doing that is, or one of the ways we can do that, is we would build another control that would contain multiple shopping lists. So now we're going to build a control that allows us to swap between them. And I'm going to call that control List Swapper. So again, a new user control, List Swapper. Let that build for a moment. All right. So now we have our list swapper. It's set up pretty much the same way. I'm going to also change our design width here to about 200. So that shrinks it back down, gives us that same aspect ratio. And then I'm going to switch to the vertical split. Center this in the space. And in this one, I am going to go ahead and use the grid. And the grid, we want to split up into columns and rows. And we do that with column definitions. And we could try declaring it with this property style here, but the problem is column definitions is a collection of column definitions. And this just really doesn't lend itself well to collections. I mean, how are we going to put multiple things in this string there? So XAML actually declares or offers us a second syntax for declaring properties where we do it inside as a child of the component it belongs to. So when we say grid column definitions, what we're actually saying is that this is the column definition property of this element, but we split it out into its own element so it's easier to express, and so we can actually put multiple things inside of here. And we'll do those as elements as well. So column definition, column definition. And I'm going to do 2. Nope, I'm going to do 3 because I want 3 buttons at the bottom. So that gives us 3 equally spaced columns. So if we don't give any width attribute to these columns, they are by default going to split all of the available space amongst themselves evenly. And the width that they are actually assigning themselves is 1 star. And the star just means split according to the ratio, and the 1 says I want to be just as big as everybody else. We'll see that here when we do a row as well. So we'll do grid.row definitions. And so we'll go ahead and have a row definition object and a row definition object. So we're going to have 2 rows. We want this one to be down at the bottom. We're going to put 3 buttons in it, so we really don't want it to contain a lot of space. So we'll give it a recommended height of maybe 60. There we go. So that you can see how that pulled down that row, and it's showing us that this is actually a height of 1 star. And we could actually explicitly state that as well. This just says break up the remaining space evenly with any other elements in that space. If I were to add a third row definition in here, maybe do 2 star, then it says I want twice as much of the available space as the 1 star elements. So these are actually a ratio, and you can use that to kind of scale out your grid in a responsive way. You can kind of pick how you want that done. So this is basically what we're going to do. We're going to put 3 buttons across the bottom there. And the first one we're going to do is we'll call it prior, because that's going to take us to the prior screen. And then to put it in the bottom left where we want it, we have to actually set the grid.row equal to 1. So that pushes it down to row 1. Now these are 0 indexed columns, 0 indexed rows. So we have to kind of follow that. We're going to put that down at the bottom. We're going to do a second button, grid.row equals 1, and this one's going to be in column 2, which is grid.column. And that will put it over, and then inside this we'll go ahead and say add, oops, not column 2, 0 indexed, column 1. Add list, so this will create a new list for us, and then we'll do button grid.row equals 1, and this one will be grid.column equal 2, and here we'll do next. And then to kind of enforce the idea that we're moving left and right, it'd be nice if we could do a less than and a greater than. Now, we can't actually use the actual symbol because obviously that has special meaning of starting a tag in XML. However, there is a special sequence which is and LT semicolon. You may know this from HTML. It also applies in XML. This stands for an and, a less than. So you notice, or it's hard to see, but we put a little less than symbol on that side of the prior. We'll do the same thing on the next with an and GT for greater than, and that gives us a button pointing to the next. And that kind of wraps us up there. Now our list, our shopping list, we actually want to display on top of all 3 of these rows. So we're going to have to do something a little bit special there because we're going to have to span all 3. And we could just declare a shopping list instance. And notice that it throws this local on the front, and that's because it's defined in the solution, in the namespace of the solution. If we come up to the top where we've declared all these namespaces, notice this is what that corresponds to, local. CLR stands for Common Language Runtime. That's the virtual machine that C# programs actually run on. So CLR namespace shop easy. So we're saying this is in the shop easy namespace. And of course, if we go look at our shopping list backend code, or even the front end code, you can see this is declared in the namespace shop easy. Okay, so that's basically just bringing in that shopping list, and notice too that suddenly this list just disappeared. That's because this hasn't been built, and we need to have this built and have the DLL available for the designer to be able to actually figure out what that's supposed to look like. So if we want that to show back up, we have to build our project. So we'll give that a moment. And now you can see that once it compiled, it went ahead and inserted in our shopping list, and it's appearing in that very first column. Now we want it to span all 3 of the columns, and the way of doing that is we'd come in here and change the grid.column span property and say that we want it to span 3 columns, so it spans all 3, and then it fills up that space. So that kind of shows what we're after here. Now, we also want the shopping list to be managed by this control, and we want to be able to have more than one of those. So we really need to be able to swap one shopping list for another, and we have to hold on to them. And we want to hold on to them in memory somewhere, and the way we do that is through variables. We have to have a variable in the code behind that's going to be representing this shopping list, and be able to swap that for another shopping list that we're holding in another variable. So really we don't want to program or decoratively put this shopping list in. Rather, we want to have a container that we can stick that into. And one of the easiest containers to use for that purpose is a grid. So we'll just go, or not a grid, a border. Now a border is really just a box that draws a line around things, capital B. And you'll notice that we actually don't show the border here, and that's because we haven't actually set a color and we haven't set a thickness, but that's fine because we just want to use it as a box to shove things into, and we want that box to go ahead and span those 3 columns so that it just automatically, whenever we put a shopping list in here, it will fill up the available space. So to expose that border in the code behind, we need to give it a name, and let's call this container grid, because that's what we're using it as a container. Okay, now if we drop to our list swapper code behind, we're going to create a couple of event handlers. So the first one we're going to create is for add new list, and of course we have to have the object sender and the routed event args e. And we'll do the same thing for void prior list object sender routed event args e. And finally, if I could get below it, void next list. And routed event args e. Okay, so that gives us a couple lists that we can work with, and then we also need a way of holding on to the various shopping lists that we've created. And we said we could put them in a variable, but since we're going to have multiples, that variable we're actually going to use a collection. So we'll create a list of shopping list objects, call this list, and it's going to be a new list of shopping list objects, and that's going to be where we collect all of our shopping lists. So when we, for example, click the add new list, we'd want to create a new list. So maybe var list equals new shopping list. So we'll create that, and we want to stick that into this lists here with list.add list. So we're putting it into this list that we're sharing, and then we need to show it in that grid on the outside. So we'll do lists dot, or sorry, what do we call that? Lists, list container? No. Container border. No, what did I call that? Container, well, it's not a grid, so let's change this to border so that it actually makes sense. Container border. And then here, container border, and we want to set this as the child. So if what we're working with is a WPF element, it will either have a child property or a children property. It will have child if it's most types of controls can only have a single child. The container elements can have multiple children. In this case, because it's a single child, we'll just set it equal to the list. That will remove whatever was currently in that border and replace it with this shopping list. So now that will appear into that container. For the prior list, we want to go to the list that occurs before the one in this list, and for next list, we want to go to the one after the list that we're currently looking at. So we need to also know what list we're currently looking at. And an easy way of keeping track of that is just to have an index. And we'll just call that current list index. And we'll set that to 0 to start with. I mean, technically, when we start, this list is an empty list, so we're not holding any. But down here, when we first add this one, we want to actually make sure that we also set the current list index to be that one, which would be the last one in the list. So we can go ahead and do that by, before we add it to the list, actually, we can set current list index equals list dot count, because we know that the count of items in the list is always one larger than the last index in the list. So if we set this first and then add the list to that list, we'll actually now have that index referencing that one that we just added. So in our prior list, when we try to go prior, probably the first thing we need to do is make sure that the list is not empty. So list.count, or lists, if that's 0, we don't want to try to display anything because there's nothing to display. So in this case, we'll just do a return, which will stop execution. We won't go any farther, and we'll just stop at that. And we actually want to do that with the next list as well, because there's no point in trying to switch list if there's no list to switch to. Then if we get past this, we want to, in this case, because we're doing the prior list, we'll decrement the current list index, so we'll move it back by 1. And then when we do that, it's very important that we make sure we don't go past 0. So if current list index is less than 0, we will reset it to be 0. And once we've done that, we're ready to go ahead and show that list by adding it to container border dot child equals lists current list index. So what we're doing here is we're changing which list we're showing in that border by grabbing the new current list index item out of the lists and setting that as the child. So that will swap for the prior list. And we'll do the same thing down here. So here we'll do current list index and we'll increment it. So we'll grow it by 1 plus plus. And then we'll also check that we haven't gone past the end of the list. So if that is greater than the lists.count minus 1 is the very last index. So if we're greater than that, then we want to set current list index to be lists.count minus 1. So if we try to go past the end, we're just going to set it back to the very last element. And then we again do the container border dot child equals lists current list index. And that's going to go ahead and set us to show whatever that one was. So these are our 3 event handlers. We jump back to our XAML. We'll go ahead and hook those up to our buttons. So on the prior, we'll say the click event handler, not content, click, equals prior list. And for the add list, we'll say click equals add new list. And for the next, we'll say click equals next list. So that hooks all of those up. And we're ready to go. Now there is something important to show. Notice that in that border, by now it no longer shows the shopping list because we haven't declared one declaratively, because this is all happening in the code behind now. And that's normal. If it's actually added in the code behind, it will not show up in the designer. Only the declaratively declared stuff will show up in the designer. So we'll save those changes. Then if we go to our main window, we want to go ahead and use that shopping list here. So I'm going to remove this checkbox I did right at the start, and we're going to replace this with that local list swapper. So a list swapper instance. It's going to fill the available space of that main window. Zoom out a little bit. And then you can see it stretches it to the size space that main window actually is. So we get these huge buttons in this very huge space. And I don't really want this to be that wide, so I'm going to set this maybe back to 300, which remember we designed it at 200, so this is actually a bit wider, but it's kind of got a somewhat pleasing aspect ratio there. And then if we go ahead and run this, you can see it looks pretty much like we expected. Minimize this. So we have a window, we have hopefully where the list is going to go, we have the prior and the next buttons. If we click those, nothing happens, as we'd expect because there's no list yet. If we click add list, we get our shopping list for, and we can go ahead and put in a store, and maybe we're in the market for a Mr. Fusion, and perhaps a flux capacitor. And of course, we might want a hoverboard. And once we're done with one shopping list, maybe we're ready for another store. So maybe we're going to go to Dylan's and maybe get some of that fruit to see if we can blend it. So apple, banana, pineapple, why not? Get some items there, and if we go back to the prior list, notice that we switched for the Radio Shack. If we go to next, we switch back to Dylan's. We can't go past either one of those, and we can add another list if we want to go to another store. Maybe we want to go to Walmart, and we're shopping for laundry baskets and crayons. So now we have our different lists. And you can see I didn't actually get this added, but notice it's still there. So as soon as I push the add, it moves back up. So these components are now we've built this application out of a couple layers of abstraction using components in composition, which is building a component from other simpler components. That's really kind of the core idea here. Now we might want to go back and think about, for example, these buttons, because it looks like you can still go on to the next list. That might be a little bit deceptive. We might want to think about disabling those. That's actually pretty easy to do. So if we jump back to our list swapper, for example, we can do that by setting an isDisabled property, or isEnabled. Set that to false for the two that you shouldn't be able to use yet, because there's no list when we start. And then we'd have to go back into our logic of the list swapper as well, the backend logic. And basically, as soon as we add a list, we'd want to make those buttons enabled, which before we can do that, we also need to give them a name. So this is name next button, and name equals prior button. And if we come back into our list swapper backend logic, code behind, then we could say once we've added a new list, we know that that list is going to be the last item in the list. So if lists.count is greater than 0 or greater than 1, because we really can't go on to the next list until there's more than 1. So if there's more than 1, then we could say prior button dot is enabled, set that equal to true. So now we should be able to use that button. If we hit the prior list button, if we get to the point where the current list index equals 0, that should mean that we can't go back any farther. So we want that prior button to be disabled at that point. So now it would be false. And then the prior button, when we're clicking next, anytime we click the next button, we know that there was at least one list behind us, so it's safe to enable that button at that point at any time. So is enabled equals true. And then we do the same thing for the next button. So here, for example, if we hit the prior list button and we've moved backwards, we know we can now move forward by default. So we'll go ahead and say next button dot is enabled and set that to true, and that's always going to be true if we hit the back button. And then the same thing conditionally here, if we click next, as long as we're not at the last item in the list. So if current list index less than list.count -1, so we're somewhere to the left of that, then we can say next button dot is enabled and set that to true. And also, if the current list index equals 0, so if we're at the front of the list, next button, or sorry, not next, previous button, prior button, equals false, and the same thing here. So you notice that we're starting to see a lot of logic being built up that's really kind of similar logic, and whenever we start doing that, and we're doing that in multiple places, it's really a good idea to pull that out into a helper function. So here, let's go ahead and just create a void enable or disable buttons. And all we're going to do is check to see if current list, or actually if lists size or count equals or is less than 1. So anytime we have just one list or 0 lists, we don't want either of those buttons enabled. So prior button dot is enabled, we'll set that to false, and next button dot is enabled equals true, or false as well. So if either of that case isn't true, then we wouldn't do that. And then we'll say else if index current list index equals 0. So now we know the list has more than one entry and that the current list index is 0. We would want the prior button to not be enabled because we can't go back any farther. We're already at the front of the list. So we'll set that to false, and next button is enabled. We'll set that equal to true. And if we're at the end of the list, so current list index is equal to list.count minus 1. So this is when we're at the end of the list. We want the prior button to be enabled, because we can always move backwards at this point, but the next button needs to be disabled. So we'll set that to false. And finally, if none of those is the case, we're somewhere in the middle of the list, we'll actually set both the prior button is enabled to true, and also the next button will be enabled. If we do this, now we can invoke that helper method, and we don't have to do all of this logic here. So all of this can go away, be replaced with an enable or disable buttons call. The same thing here. We can do all of this replaced with enable or disable buttons. And actually we could even do that, we need to do that here as well. So instead of doing this logic, we can just again call enable or disable buttons. And then also we can do this immediately after we initialize the component. And if we do that, then we don't even need to do the is disabled, is enabled over here decoratively. Now we can, it won't hurt to do, but we'll just be resetting it. And so it's just a matter of if you want to see it in the designer or not. So if we save those changes and go ahead and run this again, notice that our buttons start off disabled. As soon as we add a list, they still stay disabled because we only have one list. We add another list, suddenly we have the ability to move back to the prior list. And once we've moved back to that list, the prior goes away and the next appears. If we do 3 lists, then we can go back through the 3, forward through the 3, and our disabling of buttons happens exactly like we'd expect. So that gives us a whole host of options of things we can do with just a little bit of simple functionality. And that really kind of helps emphasize just how powerful this component-based design idea is for creating very simple controls that nonetheless, when we combine them in certain ways, give us a lot of flexibility, a lot of power. So that'll wrap us up for today. Stay healthy.